Hello and welcome to the video 7 of the trigonometry video series. In this video we are looking at bearings. What are bearings? Well, there are two types of bearings, but we'll have a look at each of those. Bearings use angles to give the direction from one place to another. Two types. We have true bearings and we have compass bearings. True bearings, they give a direction measured in a special way. They give a direction measured clockwise every time and starting from north. For example, if we wanted to draw a true bearing of 120 degrees, we'll have a bit of a compass diagram here, north, east, south and west, and we'll always go from north. And we'll need to go clockwise from north, and we'd need to go 120 degrees around there. So let's have a think about how we do that. Now, from north, a quarter of the way around would make 90 degrees. So we'd have 90 degrees if we get to that east line. Then we'd have to go a little bit further from that to get 120. Now 90 plus something to make 120, we'd need to go an extra 30 degrees there. Now, in some questions that you'll see soon, we have to also think that in that bottom quarter here, if we've used up 30 degrees, we also know the angle in here to make up that bottom 90 degrees, that bottom quadrant there, and that would be 60 degrees. So we're getting to know our way around that compass diagram there. A bearing of 120 degrees went from north around 120 degrees until we get to the right direction. Now, compass bearings, they use the major points of a compass. There are 8 of them. We have north, south, east and west. Could have guessed those, I think. And we have the ones that are halfway between each of those: northeast, northwest, southeast and southwest. And we'll have a look at those on a diagram here. Now, when we talk about northeast or northwest, the breeze is coming from the southeast or whatever, in day-to-day language we often talk about these directions roughly. When we say the breeze is from the northeast, it might not be exactly from the northeast, but that's the rough direction. With compass bearings, when we're studying trigonometry though, if it says northeast, we can trust that it's exactly halfway between north and east. If we say southwest, that's a direction that we can count on as being exactly halfway between south and west. So we can count on an exactness in trigonometry. So let's compare the compass bearings here with the true bearings of before. If we're going from north, we'll use that as our 0 sort of bearings marker. Now, to move around clockwise in a northeast direction, we will have moved exactly 45 degrees. See what I was saying about we can count on that exactness? So that it would have that northeast would have a true bearing of 45 degrees. And notice each of our true bearings in the red there has 3 digits to it. So that's an important aspect of true bearings. They have 3 digits all the time. Now, I've already had a mention of 90 degrees being straight across to east there. So I've moved around from north 90 degrees to get to the east line. The true bearing of southeast would be 90 degrees plus another 45, so it would have a true bearing of 135 degrees. And can you guess what the true bearing of south would be? How far around from north would you go to get a straight angle there? You'd get 180 degrees. So south would be said to have a true bearing of 180 degrees. Southwest, we'll add another 45 degrees there and get a true bearing of 225 degrees. 3/4 of the way around, and there is 360 degrees in one revolution there, 3/4 of that is 270 degrees, and we could also think of that as having had 90 degrees around to east, another 90 degrees to get to south, and another 90 degrees to get across to west, making a total of 270 degrees there. Now another 45 degrees there would get us to 315, and we could move another 45 degrees to get right around to the start again, and then we would have travelled 360 degrees there altogether. So that's compass bearings and a little bit of how they relate to true bearings. Now with compass bearings, we talk about quadrants. that green there that I've shaded in so beautifully, practicing my colouring in, that's called the northeast quadrant. Any angles between 0 and 90 degrees we'd say were in the northeast quadrant. Over there in the red, lovely piece of colouring again, Mr. Blake. Anything between 270 degrees and back to 360 degrees there would be said to be in the northwest quadrant. Down the bottom there, between 180 degrees and 270, we'd call that the southwest quadrant. And underneath there, we've got anything between 90 degrees and 180 degrees. We have the southeast quadrant. So 4 quadrants. Another diagram here just to show you the different quadrants there. So the question might talk about quadrants, but that's just really the 360 degrees broken up into 4 quarters there. Okay, here are some of the questions we can get. This one asks us to write the true bearing of the direction indicated by the blue line below. Now, if it's a true bearing, let's remember that true bearings give a direction measured clockwise, always, from north. So we'll ask ourselves, how far is this direction clockwise from north? How far have I gone from north around clockwise to get to the blue line there? Now you'll see there's an indication of 50 degrees here, and there'd be 90 degrees between north and that east line there. So can you calculate how much would be moved around from clockwise from north in this situation? Yep, that red arrow there would have moved around 40 degrees. We know that that quadrant there adds up to 90 degrees. So how far is this direction clockwise from north? 40 degrees. Now I did mention briefly that true bearings always have 3 digits to them. So our final answer there, we'll write it as 040. That's the true bearing of the direction in blue. Okay, here's another direction. They want the true bearing of the blue again here. We've got 40 degrees indicated here, but that's not our bearing because true bearings, once again, have to be measured clockwise and going from north as our 0 line, really. So we ask again, how far is this direction, the blue direction, clockwise around from north? Now if we go where we've done there on the red, how far around to there? Well, that would be 90 degrees so far. Then we have to go another further number of degrees to get to the blue line. And this bottom quadrant, this southeast quadrant here, would add up to 90 degrees altogether. So can you see that we'd have to move past that east line a further 50 degrees. So overall, how far have we moved around from the north? Well, it'd be 90 degrees plus the 50 degrees, and we'd get a final answer of 140 degrees. Now, that 140 degrees is already a 3-digit answer. So we can just write down that true bearing is 140 degrees. The true bearing represents how far around from north to the direction we're considering at the time. Another one, we've got 20 degrees here between the west line there and our blue line. Let's see what that means for our true bearing. We ask again, we're going from north and we're all going clockwise every time. We can't go the shortcut way or anything like that. How far is this direction clockwise from north? Let's consider how far around from north we've gone if we head off to the right hand side. Well, if we go a quarter of the way, that's going to be 90 degrees. Another quadrant would take in another 90 degrees, making 180 degrees so far. Can you calculate in your mind what this gap here would entail? How many degrees would be in that gap? Well, if you think about that bottom left-hand corner, that southwest quadrant, each of the quadrants have 90 degrees in them. So I think you might be able to tell that that last section would have 70 degrees in it. So if we add up 90 plus another 90 makes 180, plus 70 we'll get 250 degrees. So our true bearing is 250 degrees. Now some of you would have been thinking, okay, there's a bit of a shorter cut here, Mr. Blake, and that is the fact that we would have had 270 degrees to get around to the west line, 270 degrees. So this blue line is 20 degrees short of that 270 degree line. So we could have done 270 minus the 20 degrees to get our answer of 250 degrees. So there's two different ways of thinking about how we could get our answer there, but we arrive at 250 degrees no matter what there. Okay, this one. Now there's a long way around and a shortcut way here as well, but we're still asking how far around clockwise from north do I have to go till I get to the direction I'm considering. Okay, so we could go the long way here. I'll show you the two methods. 90 degrees for that first quarter, another 90 degrees for there, so we've got 180 degrees so far. Another 90 degrees there, so we're got to 270 degrees so far. Now can you see how much is going to be in this gap here? We're considering that northwest quadrant would add up to 90 degrees altogether, so we would have another 60 degrees to go. So we've got 90, 180, 270, 330 if we add all that up. Okay, now some of you will have seen already that there's a bit of a shortcut here, a bit quicker than I've been doing already. You've probably got the answer in half the time that I did, but still, it's best to know a couple of different ways to do things if they exist. One lap around and to get right back to north again, one revolution is 360 degrees, and this blue direction is 30 degrees short of 360 degrees, so we could have done for our final answer 360 minus 30 and got 330 that way. So whichever direction we go, our true bearing will always be clockwise and always starting from north. Okay, now this one asks us to draw the true bearing. The previous ones gave us the direction, and here we've got to draw the true bearing of 170 degrees on here. Okay, clockwise from north. How far around do I go clockwise from north to illustrate a bearing of 170 degrees? Now, one big guide here is that straight down, if we go around to the right, the clockwise direction, to get right down to south here, that would be a bearing of 180 degrees. So we would be expecting our directional arrow to be just short of 180 degrees. We'll use that as a bit of a guide here. Okay, so that would be 90 degrees. Now, how far more do I need if I'm going to draw 170 degrees? 90 plus what is 170? We could do 170 minus 90 on our calculator, and we'll get another 80 degrees that we need to draw before we draw that directional arrow. So we need to go around 90 plus another 80 would give us our 170 that we need altogether. Now, just to double check the second way that we're thinking of this, how far short of 180 would we be expecting to draw this directional arrow? Well, we'll compare the 180 and the 170 there. We'll have a little 10 degrees in that gap there. So it should only just be to the right of that south line. So there's a couple of different ways of just positioning that blue arrow in the correct position to illustrate 170 degrees for our true bearing. Alright, just to recap, true bearings, as I've said a number of times here, I think we should be used to this, probably sick of it by now, but still, true bearings give a direction, measured always clockwise and always from north. Compass bearings, they use your major eight points on your compass. You've got north, northeast, east, etc. all the way around there, and you can think about what true bearings they would relate to. Okay, that's a video on bearings basics. Now the next video that's coming up will deal with some problems involving bearings, and we should be nice and ready for that, so we know all our way around compass bearings and true bearings from this video. So we'll see you next time to solve some more problems. Don't forget, there's a website you can go to for lots more videos, for lots of help you need with your math skills. So all the best with that, and we'll see you next time for some bearings problems.